All right, let's dive into one of the deepest, most profound mysteries in all of science. We're going on a hunt for something that makes up most of the matter in the universe, something that literally sculpts galaxies and holds the entire cosmos together. But here's the catch. It's completely, totally invisible. We're talking about the universe's hidden skeleton, dark matter. Okay, let me just start with this. What if I told you that 85% of all the matter that exists, the stuff that makes up galaxies, stars, planets, even you, is something we can't see, can't touch, and can't detect in any normal way? I mean, that sounds like science fiction, right? But it's not. That's the actual reality we're living in.
Just take a look at this breakdown of our universe. Everything we know, everything we can see, every star, every galaxy, every planet, all of it is crammed into that tiny 4.9% sliver called normal matter. The rest? Well, that's the mysterious dark sector. A massive chunk, over 68%, is something called dark energy, which is a whole other story. But our focus today is on that other big piece of the pie, that 26.8% we call dark matter.
So you have to wonder, how did we even figure out something was missing in the first place? Well, this is a genuine cosmic detective story. It all started when astronomers were looking at the universe on the grandest scales and realized the numbers just didn't add up. There was a serious case of missing mass. Our main guidebook in this whole investigation is a framework called the Lambda CDM Model. You can think of it as our best guess theory for how the universe works. It's built on three main pillars: Lambda, which stands for dark energy, CDM for cold dark matter, and of course, the normal matter we're all made of. And look, this model is unbelievably successful, but it has one huge requirement. The whole thing only works if this invisible matter is real. Okay, so where's the proof? I mean, this is a pretty wild claim. The case for dark matter isn't built on just one thing. It's actually built on a trail of really compelling, kind of ghostly clues that astronomers have been gathering from all corners of the cosmos. So let's follow that trail. Our very first clue actually comes from looking at galaxies, kind of like our own cosmic neighbors. See, astronomers expected that stars on the outer edges of a galaxy would move slower than the stars near the center, just like in our solar system where Pluto moves way slower than Mercury. But that's not at all what they found. Yeah, it turns out the stars on the edges were moving just as fast, sometimes even faster than the ones on the inside. Now, based on the gravity from all the stars and gas we can see, these galaxies are spinning so ridiculously fast, they should have literally torn themselves apart billions of years ago. The only way this makes sense is if they're embedded in a giant, invisible halo of matter that's providing the extra gravitational glue to hold everything together. All right, our next clue comes from one of Einstein's coolest predictions, that gravity actually bends light. Big, massive objects literally warp the fabric of space-time, and light has to follow that curve. So what does it mean when we see light being bent by, well, what looks like absolutely nothing? So when we look at these huge clusters of galaxies, we can see the light from even more distant objects behind them getting stretched and distorted, almost like you're looking through the bottom of a wine glass. This effect is called gravitational lensing. And the amount of bending we see tells us there's way more mass, and therefore way more gravity, than all the visible stuff could ever account for. Lensing basically gives us a map of where the mass is, and that map is pointing to huge clumps of invisible stuff. But the real smoking gun, the single most powerful direct piece of evidence we have for dark matter, it came from watching one of the most violent events imaginable: two entire clusters of galaxies smashing into each other. This right here is the bullet cluster. On the left, in pink, you're seeing the normal matter, mostly super hot gas. When the clusters collided, this gas crashed together and slowed way down. But on the right, in blue, is where gravitational lensing tells us most of the mass is. And that mass, it didn't slow down at all. It just passed right through like a ghost. This was it. This was the moment we could actually see the normal matter in one place and the source of all the gravity in a completely different place. So the evidence is pretty overwhelming, right? Something else is out there. So now that we have all these clues, it's time to do what any good detective would do. Let's build a profile of our prime suspect, dark matter itself. So what is this stuff? Well, by definition, dark matter is some kind of matter that isn't made of protons, neutrons, or electrons like you and me. And it's called dark for a really simple reason. It just doesn't interact with light at all. It seems like its only known superpower is gravity. And the profile gets even more detailed. We think it's cold, which just means it was moving pretty slowly in the early universe. And that's super important because that allowed it to clump together and form the gravitational seeds for galaxies. Really, that's its most important job. It's the universe's architect. It formed this vast, invisible cosmic web, a sort of gravitational scaffolding that all the normal matter fell onto to create the stars and galaxies we see today. You know, to make this a little easier to picture, let's use an analogy. Let's just imagine for a second that the entire universe is one giant building. So in this building, all the normal matter, that's the stars, the planets, us, we're just the furniture and the people walking around inside. Then you have dark energy, which is this weird force that's actively pushing the walls of the building farther and farther apart, making it expand. And dark matter, that's the invisible reinforced concrete frame of the whole building. Without that frame, the building never would have formed in the first place and it would just fly apart. So we have a profile. We know what it does, how it behaves, but we still have no idea what it is. And this brings us to the particle lineup. All the leading candidates for the secret identity of dark matter. For a really long time, the number one suspect was something called a WIMP, a weakly interacting massive particle. But, well, we've been looking for them for decades and haven't found a thing. Other crazy ideas include things called axions, which are super lightweight particles, or maybe even primordial black holes that could have popped into existence right after the Big Bang. The honest truth is, nobody knows for sure. And honestly, that's what makes this all so incredibly exciting. Even with all this powerful evidence that it exists, the case of dark matter is still wide open. It is, without a doubt, one of the biggest unsolved mysteries in all of physics. And you know, the plot thickens, because our standard cold dark matter model, as good as it is, isn't perfect. For example, it predicts there should be a lot more tiny dwarf galaxies orbiting big ones like the Milky Way than we've actually been able to find. It also says the very centers of galaxies should have a sharp cusp of dark matter, but when we look, we often see flatter cores. These are like little cracks in the case that keep scientists digging for more answers. These little cracks have led some scientists to propose a pretty radical idea. What if there is no new particle? What if our theory of gravity is just wrong, or at least incomplete on cosmic scales? This alternative idea is called MOND, and it's fascinating. It can explain why galaxies spin the way they do without any dark matter at all. But it has a really hard time explaining evidence like the bullet cluster, where gravity and matter are clearly in two different spots. So yeah, the hunt is very much on. Right now, as we speak, deep underground in labs shielded from all kinds of cosmic noise, experiments like LUX-ZEPLIN are just sitting there, waiting patiently, hoping to catch the absolute faintest signal of a dark matter particle bumping into one of their detectors. This is real science happening on the absolute frontier of what we know. So there you have it. We've got a cosmic crime scene. We have a trail of ghostly clues from speeding galaxies and bent starlight. We have a lineup of weird and exotic suspects. We have a really detailed profile of what this mystery substance does, but its actual identity is still completely unknown. And all of that leaves us with maybe the most profound question we can ask about our own universe. What is the 95% of everything that we can't see actually made of?